Okay, so here I have a prototype for a motorcycle cruise control. I'm going to start by just going over how everything works together. First of all, I have a flywheel. This is just going to act as the motorcycle's actual wheel. Attached to the flywheel, if I rotate it a little bit, we can see that there's a magnet right here embedded in. This way, every time the flywheel makes a revolution, the magnet passes in front of this sensor right here. This is called a Hall effect sensor. All it does is whenever it senses a magnetic field, it sends a signal to the output. That signal is going to go into an Arduino at the bottom of this housing. On the Arduino, there's going to be, there's code for PID control. PID control adjusts the voltage going to the DC motor, which is attached to the flywheel. That way I can control the flywheel's RPM. Anyways, moving on to the button controls. Here we have a potentiometer. This potentiometer I'm going to use to initially set the RPM value. Just like in a car cruise control, how you first have to get up to the speed that you want, and then you can press the button, and then the car will maintain that speed. I want to do the same exact thing. Just going to adjust this potentiometer until it gets up to an RPM that I like, and then I'll press this button. Over here on the left side, first we have the buttons which I can use to adjust the set RPM. So again, just like in a car, if I want to increase or decrease the set speed, I have buttons to press, or a lever in many cases. I want to replicate that, so I have these two buttons. This one right here, just a reset button, pretty self-explanatory. Press it, resets the Arduino. Yeah. Over here at the top, this LED, it acts as an error light, so that whenever something goes wrong, it goes off, and then that way I can know that's why the Arduino is turning itself off, just for safety purposes. We also have the two power switches. This one does nothing. It was supposed to be able to power on and off a component, but unfortunately Amazon didn't deliver it in time, so really it's just here for aesthetic purposes now. Better than a hole in the lid, right? This one actually turns on and off the Arduino. Right now it doesn't really do anything, purely just because the Arduino is currently hooked up to my computer. That's where the power is coming from. Going over to the computer, I wanted to show in real time how the system responds to different things I do to it. So I'm going to apply resistance to it. I'm going to try to increase speed, decrease it. I'm going to set the speed. All the stuff that a cruise control is supposed to do. And I wanted to show in real time how all that works. So getting started, I'm going to increase the potentiometer's value until the flywheel starts moving. It needs a little bit of help. There it goes. Right. So I'm able to, if you can hear, I'm able to increase or decrease the RPM of the flywheel just by turning this potentiometer. Looking at the graph, again, I can either decrease or increase. Now, something I do want to point out while we're here are the fluctuations in the RPM value. That's because of the DC motor and issues with it. If you listen closely, you can actually hear grinding coming from the motor. That's because one or two of the teeth are actually broken, and unfortunately, I wasn't able to get a replacement part in time. So unfortunately, there's nothing we can do. We just have to deal with it. So anyways, for this presentation, or this demonstration rather, I'm going to just set this RPM value at a nice kind of middle ground 600. Almost there. We also have the automatic adjusting of the Arduino code. Okay, that's about 600. We'll keep it there. Right, so this is the value that I want. Press the button, and I set it. Ignore the spike. For some reason, Arduino doesn't like button presses. So every now and then you get a spike there, and you'll see that later on. Again, that's just the Arduino acting weird. Okay, so after that I press press the button, 3 new values appeared on the screen. First, I want to bring your attention to the green one, as it starts to hide behind the blue line. That is the set value that I have for my RPM. So like I said, I wanted it at around 600, so that green value is going to maintain a 600-ish value. Going down, first we'll look at the red line. That is the error value. So it's really just the difference between the set RPM and the actual RPM. The yellow value is the motor power, and you'll see how the motor power is affected and how the system responds. Okay, so I'm going to start by applying a small force, resistive force, to the flywheel. Try to keep it constant to make things simple. As you can see, it goes, the RPMs drop, and to respond, the motor power increases until the error returns to 0. Keep it straight. The error returns to 0, and then it maintains that motor power value. So now I'm going to release the resistive force, and you'll see a large spike in the RPM and error. So that spike is caused from the motor power all of a sudden not needing, the motor not needing all that power, and you'll see that the RPM suddenly increases, and then it kind of fluctuates and then comes back to rest. This is actually the PID control, using damped oscillations to maintain a 0 value for the error value. Anyway, so let's say now that I apply a resistive force that's just too much for the motor to control, or for it to handle. You'll see that the motor power begins to maintain the constant value, and the error and RPM values just kind of do this weird thing. That's just purely because the motor doesn't have enough power, it doesn't have enough voltage to be able to overcome this force. Okay. And not sure if you heard, but at some point the flywheel reached 0. It just started moving too slow. So error light came on, and it reset the flywheel, the Arduino rather. Okay, so again we're at about 600. Set this value. So now let's say I want to use my 2 buttons here to increase and decrease the set RPM value. So I'm going to start by decreasing it. So I'm just going to press it a few times, and you see that the motor power decreases, RPM drops, and error value returns to 0. Now I'm going to increase it, go back up to about 600, and again you see motor power increases, RPM increases, and error value gradually becomes 0. And just to kind of have fun with it, you can see, just kind of follows whatever shape the desired RPM value takes. Just a small delay, of course. Right, so pretty sure that's everything. I hope everything made sense. I hope you guys liked it. Thanks.